Hello everybody, welcome back to Logic 1000. So now we're doing things in this online format. So we were partway through chapter 2 already. I've decided just to back up and redo it. I'm going to post all the slides I'm going to go through here. So there is going to be some repetition in the content. If you're already happy with what you've learned from what we did in class, feel free to just skip ahead in the video until you see some new content. I've revised a couple slides ever so slightly. One thing I'm going to emphasize at this point is to definitely read the text I gave you. I was going to reiterate this and emphasize it in class anyways, but I'm going to do it now. I could write up very detailed notes of everything I'm going to talk about. That's what I did. That's what the text just is. Those are my detailed notes trying to walk you through step by step what it is I'm talking about. I'm going to do my best in these videos and using the slides to show you what's going on. In some ways, I might move a little bit quickly through some of the basic concepts, and that's precisely why the text is there, so you can go back and take a look at what some of those concepts are. There's one advantage as well to actually moving to this online format for this part of the course, which is that you can go back and re-watch some explanations. So if I move through something a little bit quickly, something seems a little bit odd or just isn't quite clicking for you yet, it just doesn't quite make full sense, go back, re-watch the video, read the text, take a look at the slides, try to make good use of all of these resources. And as I've said before, if you do have questions, feel free to contact me, send me an email or Skype with me, or we can set something up on Zoom or the telephone or something like that. So I am happy to give you some assistance trying to figure some of this out. That said, try to make good use of the materials I'm already giving you, because if I have over 100 people all trying to reach out to me at the same time saying, yeah, there's this tricky bit that I don't quite get, I can get overwhelmed, and there might come a point where if I have too many people trying to contact me, it might really slow me down in terms of trying to respond to people. So try to make good use of the materials I give you. Now, I'm going to go ahead and switch over from this normal video to the screen sharing. So I'm going to try that right now. Give me just a second here. Hopefully I don't mess this up. Okay, so you should now be seeing the slides with me sort of tucked up in the corner here. Also, sorry for any odd pauses or delays. I'm still getting comfortable using this Zoom platform to make these videos. Hopefully within 1 or 2 videos, I'll have a better sense of exactly what's going on. I'm already reasonably confident what I'm doing. It's just a little bit tricky in terms of working with the interface and things like that. So just backing up, looking at chapter 2 of the primer here, let's talk about some of what we've already talked about a little bit, which is the concepts of validity and soundness. So as we were talking about in class on last Wednesday and Monday at least a little bit, and I've mentioned this at other points in the term, we're now looking at deductive arguments. We're looking at deduction. So in chapter 10 of Hughes and Lavery, we're looking at induction. We were taking a look at inductive types of arguments. And really what's going on in an inductive argument is that you've got premises that support a conclusion, but there's in some sense a little bit of a gap between them. So if you've got good premises, they're acceptable, they're relevant, they're adequate to ultimately support the conclusion. What an inductive argument does is gives you good reason to believe the conclusion, but it could always turn out that the conclusion's false, even though you had good reason to believe it. Now, that might sound like a problem, but we reason that way all the time. We think about how the future is going to resemble the past, how things we don't know are like things we do know. We argue about what the right explanation or correct hypothesis for something is. And in all of these areas, we lack certainty. But we can still be reasonable and can still be acting on good reason by accepting a strong argument. Now, a deductive argument is different from an inductive argument in terms of its structure. And we'll get around to this a little bit later, but arguably you can take any argument and transfer it from one form to the other. It all depends on how the premises fit together and support the conclusion. So just taking a look at the slide I have up here, The great strength of deductive arguments is that their structure unequivocally determines whether or not an argument meets the relevance and adequacy criteria of a sound argument. Now that's as outlined as Hughes and Lavery, thinking about those criteria. So it's really the structure of a deductive argument, or the structure of an argument, that makes it deductive rather than inductive. And it's deductive when it doesn't have that little bit of a gap that inductive arguments do. So inductive arguments, you've got good reason to believe the conclusion, right? You've got some acceptable relevant premises. They can even be adequate to support the conclusion. There's going to be some element of probability in there. And so there's always going to be a little bit of space where you don't have that guarantee. A deductive argument is simply one that closes that space. And if you accept the premises and you say these premises are all acceptable, they're all true or likely to be true, and it has the right kind of structure, you just have to accept that argument's conclusion as well. I'm going to emphasize a few times, and I already did this in class, so my apologies if this seems clear to you. I find this is often an issue that some people when they're first learning this material can stumble on a little bit, and it just seems a little bit tricky for them to get their heads around. When we're talking about validity and invalidity, formal validity and invalidity, these are structural properties of deductive arguments. It doesn't matter what the premises actually are. It doesn't matter what the content of the argument is. Whether or not a deductive argument is formally valid or formally invalid all depends on how those premises fit together. Really, what the structure of the argument is, not so much the content. This is part of why we're going to do so much abstract work as we're studying this kind of approach to logic and argumentation, because it doesn't really matter what the premises actually are when you're trying to figure out what the structure of the argument is. The structure of the argument can be done purely abstractly. And by doing it abstractly, we can determine whether or not the argument is valid or invalid. Now, there is a little bit of a drawback here with taking this time to really focus on determining validity and invalidity, which is namely that we aren't really advancing our ability to determine whether or not the premises of a deductive argument are acceptable. That is, whether or not they're likely enough to be true, that given the context, we're willing to accept those premises and thus potentially accept the conclusion as well. So that is one thing we're just not going to focus on too much. So you have to, in some sense, keep in mind what we've already learned from Hughes and Lavery and talked about in class when we're determining whether or not we should accept premises as true or likely true. We need to keep in mind different sources of evidence, things like our own experience, the testimony of others, anecdotal evidence from other people, just their particular experience, testimony from experts and proper authorities, multiple sources of evidence, and so on. So we need to keep that all in mind when we're determining whether or not we should be accepting premises. So just taking a look at this slide I put up here, what's going on in this case? Well, it's really this question about what is it for an argument to be formally valid? So we know formal validity and invalidity are structural properties of deductive arguments. If a deductive argument is formally valid, so this is the first bullet point, the argument structure is such that the premises, if true, guarantee the truth of the conclusion. So it's really a kind of guarantee we get in a formally valid argument if the premises are true. The conclusion has to be true as well. That's not saying that the premises of the argument are true. It's just saying that if they are, then the conclusion will have to be true as well. That is, we'll have to accept the conclusion. Otherwise, we'll wind up contradicting ourselves. We'll see what this looks like. We can state this differently. It's impossible for the conclusion of a valid deductive argument to be false if all of its premises are true. And this is the second bullet point. That really amounts to essentially the same thing as what the first bullet point says. You just can't have a situation where you have a deductive argument that's formally valid, all the premises are accepted as true, and then the conclusion is rejected as false. Now, I suppose what I said is perhaps a little misleading. You can do that. You can accept all the premises and reject the conclusion, but you will be blatantly contradicting yourself if you do. We'll see some examples of this as we move forward. So this tells us what formal validity is. What about formal invalidity? Well, really, if a deductive argument is formally invalid, it just means that it's not formally valid. So all deductive arguments are either formally valid or formally invalid. It's one or the other. There's no in between. We might not know by looking at the argument whether or not it's valid or invalid, but we're going to look at some techniques that help us figure out whether or not the argument is valid or invalid. So a formally valid argument is what we call truth preserving. That is, if the premises are true, their truth gets preserved through every step of the argument and ultimately gets preserved into the conclusion. So I've made this analogy in class before. It's like good plumbing. If you've got good plumbing, if you put something in one end, you're going to get it all out the other end. Right? If you put in a liter of water into some good plumbing, you don't have any leaks in the pipes or anything, you put a liter in one end, you're going to get a liter of water at the other end. In a formally valid deductive argument, if you put in all true premises, you're going to get out all truth. That is, the conclusion will have to be true as well. But just like leaky pipes, a formally invalid argument, you might put all truth in the one end, but you're not necessarily going to get truth out of the other. You're going to lose that guarantee. That's really what happens. Let's take a look at just a few examples of some arguments that are all formally valid, just to help show how it is that validity and invalidity are structural features of the argument. So we worked through this one in class already. If it is raining, then it is pouring. It is raining, therefore it is pouring. Now, this is a formally valid argument. If 1 and 2 are true, those are our premises, then 3, the conclusion, has to be true as well. Right? If we accept that if it's raining, then it is pouring, and we accept that literally, we're saying that if it is raining, then guaranteed it is pouring. It's 100%. It's not probably, there's no qualification in there. We're saying if it's raining, it has to be pouring. We then say it is actually raining. The conclusion that follows is that it is pouring. If we say that it is raining, and if it is raining, then it is pouring, and then we deny that it is actually pouring, we're just contradicting ourselves. Let's take a look at a couple more examples. Here's one more valid argument. Either Carl is a human or Carl is not a human. Right? Second premise. It is false that Carl is not a human. That seems like a mouthful, right? That seems odd to say. It even seems odd to argue this way and think this way. Right? But the conclusion, therefore Carl is a human. Here again, 1 and 2 act as premises. If we accept both of those premises, we say they're both true, we have to accept the conclusion as well. Seems like a strange argument. You might not even accept one of the premises. Right? You might think I'm an alien or a robot or something. You might not be wrong. But what's really important is that it's a valid argument, has the right kind of structure. If the premises are true, then the conclusion has to be true as well. One more example. Right? If Carl is a human, then the moon is made of chicken wings. Carl is a human, therefore the moon is made of chicken wings. Of course, this seems to relate back to the first argument. In some sense, that's just a little bit of overlap. I was just creating these on the spot. So look, this last argument, the one at the bottom, it's formally valid as well. Now in this one, the premises are obviously problematic. Right? Premise 2, Carl is a human. Accept that, at least for the sake of the argument. But this first premise, if Carl is a human, then the moon is made of chicken wings. 1, we know the moon isn't made of chicken wings, or at least we don't believe it. At least I don't think any of you are going to believe it. And there's just no sensible connection at all between me being a human and the moon being made of chicken wings. Right? Like, just if you think about how the world works, there's just no logical connection here. Whether or not I'm a human is just irrelevant to the truth of whether or not the moon is made of chicken wings. So the content of this argument isn't very good. We shouldn't accept premise 1. Premise 2 we'll probably accept, but maybe you don't. You're not going to accept the conclusion either. But that doesn't stop this argument from being formally valid. It being formally valid just means that if those premises were true, if 1 and 2 are true, then the conclusion, 3, would have to be true as well. We would have to accept it as true, otherwise we would contradict ourselves. That's really all it means for an argument to be formally valid. So keep this in mind as we move forward. Part of what we're going to be doing is abstracting away from the actual content of the arguments, just to be looking at the structure of it. This is ultimately what we're going to be doing as we move forward with this material. And so you might worry that we're going to lose touch with reality in some sense. That's, in some sense, a legitimate worry. But for all the abstraction we're going to be doing, ultimately what we're trying to do is develop a very powerful tool, a very abstract and general tool that we can then use to apply to real-life argumentation. So we've got to keep in mind that ultimately, when we're using these tools in practice, we still need to have an eye to the actual truth or probable truth of the premises. We still have to keep in mind what Hughes and Lavery were telling us about acceptability, but deductive arguments help give us a kind of shortcut in assessing relevance and adequacy in arguments. Now, there's this extra concept, soundness. Now, we've already seen this out of Hughes and Lavery, and they use it for basically the same kind of concept. They use it very broadly for any type of argument. We're talking about deductive arguments. If we have a deductive argument that's formally valid, and only deductive arguments can be formally valid, inductive arguments can't. All inductive arguments are formally invalid, although Hughes and Lavery would say they can be sound. When we're talking about deductive arguments, if a formally valid deductive argument has true premises, then it is a sound argument. Right? So whether or not the argument is valid or invalid completely depends on its structure. Whether or not the argument is sound depends on both its structure and its content. You can have a formally valid argument that is not sound, but you cannot have a sound argument that is not formally valid. So keep that in mind as we move forward as well. I mentioned this previously, but it's worth reiterating here. When we're thinking about arguments in terms of how we evaluate them and the criteria we use to evaluate them as outlined by Hughes and Lavery, deductive arguments, if they're formally valid, automatically meet the relevance and adequacy criteria of a good argument, of a sound argument in general. This is part of the reason that learning these deductive methods is useful, because if you encounter an argument and you look at it and you say, okay, this is a deductive argument, or I can put it into a deductive form just to help clear up exactly how the premises relate to the conclusion, then all you have to do is determine whether or not the premises are really acceptable. Right? It helps narrow down, in some sense, how much work you need to do to determine whether or not the argument is a good one. Now, we're going to be moving on to what we call truth tables. So we're into section 2.2 in the formal logic primer. I've tried to put the title at the top of most of these slides just to show where we are in terms of that primer. So as we're moving through the slides, you can go and take a look at that material if anything's not making sense. Or you can just read along with the video in terms of just chunking up how to work through the chapters and so on. So we're going to talk about truth tables. Just before we do that, here's an example argument. I use an argument like this in the book. It's not this exact argument, but something like this. Let's say we've got this argument. And you might, looking at this, even say, that doesn't even really sound like an argument. True, we're going to have to see precisely how arguments work within this logical system we're developing. And to really get a full sense of that, we're going to have to examine chapter 3. But to make full sense of what's going on in chapter 3, we need to get some sense of what truth tables are, because they help us understand what I call logical operators. So take a look at this argument, right? Premise 1, Tuesday comes after Monday. Seems true, right? I believe. We might extend that and say on particular calendars or something like this. Well, let's just leave it at this for now. Tuesday comes after Monday. Okay. Second premise, Wednesday comes after Monday, right? It's also true if we're thinking within a week, right? Of course, both Tuesday and Wednesday come after Monday. So the conclusion, Tuesday comes after Monday and Wednesday comes after Monday, right? Now, this is an argument within statement logic, in part because we've got two simple statements. Premise 1 is a simple statement. Premise 2 is a simple statement. Remember from chapter 1 that a simple statement is one that we just can't break down any further, right? It doesn't have any other statement that's a part of it. It's something that can be true or false on its own, but it doesn't have any parts that could just be true or false if we tried to split the sentence down and make it any smaller. The conclusion, though, is a complex statement. It has two simple statements that make it up. In this case, the conclusion is really just asserting that the two premises are true. might not seem like much of an argument. In fact, it's not. I've put it together just because it's so simple and straightforward, in some sense obvious, that the content of this argument shouldn't serve as a stumbling block with what we want to do to it. So now we'll keep this in mind. We're going to work through this a little bit. We're going to see what's going on with truth tables. So within our argument, right, we've got these simple statements. Tuesday comes after Monday. Wednesday comes after Monday. We're going to label those as P and Q, because of course we want to assign letters to all our simple statements. Now, every statement in an argument, when we're dealing with deduction, every statement has a truth value. The truth value is simply the value of being either true or false. So don't worry about this point too much. There are other kinds of logical systems that deal with more truth values than just these two. Well, we're going to set that aside. That's something advanced. If you want to carry on in logic, it's very interesting. But for our purposes, if we have a statement, whatever the statement may be, it's just either true or false. Now, we might not know whether it's true or whether it's false. We might think it's true rather than false, but not really be too sure. But if you sort of step outside the limits of human knowledge, every statement, and of course, a string of words is a statement if it's capable of being true or false, it either is true or false. So in our argument here, we've got our two simple statements. Tuesday comes after Monday. Wednesday comes after Monday. They're both either true or false. Now, of course, the conclusion is also going to be true or false. But to figure out whether or not it's true or false, we need to figure out whether or not our premises are true or false. So we can use a truth table to represent all of the possible combinations of statements. Now, just give me a moment here. I just want to take a little pause, so the video might hiccup for a second, and then I'm going to come back to it.